This lesson is for section 10.6 and will teach you about circles and arcs. To begin with, define circle. Circle is a set of points equidistant from a point called the center. I know you all know what a circle is, but have you ever thought about how you actually define it? We have the center of the circle, and the radii is what it would talk about equidistant, meaning equal distance, that if you take this radius and you were to draw it infinitely from that point, you'd get the circle. Think about a dog tethered in the center of a yard, that he can only go in this particular circular pattern. Central angle, an angle whose vertex is at the center. So angle, in this particular diagram, angle CPA is a central angle. Angle CPB is a central angle because its vertex is the center. Arc is part of a circle. When we talk about arc, we're talking about part of the circumference. That's an arc. This is an arc. Any of this part of the circle would be an arc. So we have central angle and arc. All right, naming an arc. We have three different kinds of arcs. We have a minor arc, which is less than half of a circle. We name a minor arc with two capital letters. So for instance, here we could talk about arc RT, and it gets this arc across it so that we know that it's not a line segment, that it is actually part of the circle. Semicircle would be half of a circle, so from TRS, and we do use 3 points to name a semicircle. And then a major arc. A major arc is going to be more than half of the circle, and we need 3 points to name this as well. So let's talk about RTS. We need 3 points so that it takes your eyes around the circle where you want someone to go. If you were to only say RS, yes, I understand that RS does go this way, but RS is specifically talking about the shortest path. We need RTS to describe that particular movement. When we talk about measurement, measurement is in degrees. The measurement of an arc is identical to its central angle, which I mentioned right down here. The measurement of an arc is equal to the center angle, and it's measured in degrees. So the idea here of arc measurement, when we talk about arc, let me erase some of this stuff. When we talk about arc RT, it's the same as this measurement in here. What I'm really looking for in this particular space is that the measurement of a minor arc is less than half of a circle. So it's between 0 and 180. It can't be 0 and it can't be 180. The measurement of a semicircle is exactly equal to 180. And the measurement of a major arc, it's going to be more than 180, but less than 360, remembering there's 360 degrees in a circle. These key concepts, like I just mentioned, the measurement of an arc is equal to the central angle. So if we want to talk about the measurement of, let me get all this out of the way again. We want to talk about the measurement of RTS. This arc is going to be equal to that central angle, which the angle is larger than 180, which is more than what you're used to seeing, but we are dealing with a circle. The other concept here is arc length. Arc length and arc measurement are pretty easy to get mixed up. Measurement, again, is measured in degrees. When we talk about arc length, we're dealing with the circumference of a circle. Think if you were to measure something circular, you would have that like kind of flat seamstress measuring tape. The idea too, think about a lampshade. If you wanted to measure the circumference of the lampshade or how much ribbon you'd need to put around it, you could lay that flat and actually measure it in inches or feet or meters or centimeters. So this is going to be a fraction of the circumference. So length is dealing with inches, something of a linear unit. When we talk about measurement of an arc, we're talking about degrees. All right, name the following. 2 minor arcs. Well, there's a bunch of minor arcs here. I see arc AD, 2 letters, AC, CE, and DE. And you could call these, like you could call it EC or CA or DA, just like with segments. Naming 2 major arcs, A, D, C. And I know that there is an E in there, but I don't want to use the E because that would give me the semicircle. I could name the semicircle this way too. So talking about another major arc. Let's see, C, E, A would bring your eyes all the way around. So we really do need all 3 points. Oops. All right, so as mentioned before, the measure of an arc is the same as its related central angle. So let's go ahead and take a peek at some of these. This one says find the measure of angle COD. COD. So the arc measurement is 58. Its central angle measurement is also 58. Find the measure, that M, of arc CDA appears to be half of the circle, so it's 180 degrees. Find the measure of arc AD. Let me get a different color here. AD is this arc right here, so it's made up of this central angle. Well, I see that there was 180 degrees if it goes all the way across. If that's 58, then I subtracted from 180. That means that angle measure is that amount, so this arc measure is the same. Lastly, find the measure of arc. Let me get a different color. B, it's a different color. BAD. So it's this whole spot right here. So we really need to figure out this entire angle. Well, we know that circles are 360, so that was 32, that one's 58, that one's 122. So I subtracted from 360, found out that this one's 148. So this out here is 148. So from B to A, wrapped around to D, is 148 and 122. So 270 degrees. All of these are masking for measurements, so they are all in degrees. All right, next page. Talks about finding length. Formula for arc length. Mentioned in the previous in that key concepts box that arc length is a fraction of the circumference. So it's going to be your degree over 360 times circumference is either going to be 2 pi r, or you can use pi d. Doesn't matter here. This is very close to when we used to find sector. When we found sector, sector was the area of like that pie shape here. So it was a fraction of the whole circle. Now what we're dealing with is a fraction of the actual crust or that edge. So we're not anymore dealing with area, we're dealing with circumference, which is length. All right, so find the measurement from X to Y. Well, I notice that the central angle is 90 degrees. 90 degrees over 360 makes up a quarter of the circle. And you can use either 2 pi r or pi d. Pi times d. And I do like things in terms of pi. So a quarter times 16 is 4 pi. And we're dealing with inches because circumference is perimeter. It's a linear unit. The next one says find the length of X. Oh, I really don't like. Well, it says, yeah, find the length of X, Y. So that's this amount right here. If the pink part of the circle is 240, then the central angle here is 120. It's telling me the radius is 15. 120 degrees out of 360 is 1/3 of the circle. So the fraction is 1/3. times 2 pi. I'm going to choose to use 2 pi r since they gave me r. So that's 30 pi. Well, 1/3 of 30 is 10 pi. Here we're in centimeters, not squared, not cubed, because circumference is perimeter, which is a linear amount. Last problem. Number 6, it says if this circle is rolled for 100 feet, how many revolutions would it make? Revolution, we're dealing with how far is it actually going. Think about taking a piece of string and laying it flat. One revolution would essentially be its circumference. All the way around once, one revolution is its circumference. So the revolution of this particular circle is 2 pi. But I'm asking if it's rolled for 100 feet. So roll this circle, how many times could you roll it and have it go a distance of 100 feet? I think I'm just going to divide. If one revolution is equal to 2 pi, then I want to know how many revolutions are in 100 feet. So 100 feet divided by 2 pi. You're going to need your calculator for this one. I got a decimal. It was 157.079. If we're talking about full revolutions, it would really, let's see, in 100 feet, I think it would need to make, well, a part of a revolution. So 157 revolutions would get it just under 100 feet. I think you would actually need this 158th one to get it to 100 feet, but then it would be over. So it's just kind of a matter about how the rounding is how it wants to be rounded, but I'm really okay with either or the decimal. All right, so that concludes this lesson. Please let me know if you have any questions.